In today's lesson, we're going to talk about three different concepts. We are going to first talk about something that's called simplest radical form. It's just a way to write a root answer in simplest form. So it's like reducing a root. So you've seen part of this already because first semester your teacher should have showed you how to do number one here, which is writing something so that it has no perfect square factors underneath the radical. So what you should have learned last semester is you can break a number like 52 into two of its factors. I broke them into 4 and 13. Now the reason you'd want to use 4 and 13 is that 4 is a perfect square. So we go to the next step. The square root of 4 can be simplified. That gets simplified to the number 2, and then the root 13 stays as root 13. So we're going to do two similar problems here, number 1 and number 2. In number 1, you want to break 20 into two of its factors. You could break it into 2 and 10, 4 and 5. Now the reason why I'm going to select 4 and 5 is because 4 is a perfect square. If I take the square root of 4, I get a value of 2, so this simplifies into 2 square root of 5. I'm going to do something very similar with 48. 48 I can break into two of its factors. Now there are several factors of 48. We could do numbers like 2 and 24, or 4 and 12, or 3 and 16. There are several factors, or 6 and 8. So which of the ones is going to be the best that I just listed for you? That best set is going to be 16 and 3. The reason why is because 16 is a perfect square, and it's the biggest perfect square that goes into 48. So I can simplify the square root of 16 to get 4 square root of 3. So that is that radical, that root, reduced in simplest form. Now something you probably did not learn last semester was how to simplify a fraction with a root in it. Simplest radical form says you can't have any square roots in the denominator of a fraction. So in number 3 and number 4, that's a problem in each problem. Okay, that's an issue. So how do I get rid of this root 5 in the denominator? What we're going to do is we're going to multiply by. So to fix the issue of having a square root in the denominator, what we're going to do is we're going to take that same root and we're going to multiply numerator and denominator by it. This is called rationalizing the denominator. So what that does, in the numerator of the fraction, you get 2 square root of 5. In the denominator, the whole reason that we do this is because square root of 5 times square root of 5 is square root of 25. Now if you notice, the denominator now is a perfect square, which means that I can simplify the square root of 25 into just 5. So I no longer have a square root in the denominator, so it is considered simplified. Very similar process in number 4. We're going to multiply top and bottom by the square root of 10. It's called rationalizing the denominator. We end up in the numerator with 4 root 10. In the denominator, I get 10. Now what we can do is we can simplify here. Now remember, with radicals, you can always simplify what's inside the root with something else that's inside a root. You can simplify something that's outside of the root with something that's also outside of a root. So the 4 and the 10 can be simplified into 2 and 5. It reduces. So your final answer, 2 square root of 10 over 5. We've got a couple more examples down here. Now, you don't have these problems in the note sheet that I gave you, but it probably would be a good idea for you to write these down so that you can work through them with me, because this is a skill that we're going to use a lot in the lesson that I gave you to watch a video over. So in number 5, we'll do a couple more examples of this. In number 5, we're going to multiply top and bottom by root 6. That gets rid of the root in the denominator. So we end up with 9 square root of 6 on top, and we end up with just 6 on bottom. Just like in number 4, we can actually reduce this because the 9 and 6 are both divisible by 3. So we end up with a 3 and a 2 on top and bottom. My end answer simplifies 3 square root of 6 all over 2. Last ones. Let's talk about number 6, and then we'll move on. First off, notice the entire fraction is under a root. So what I can do here is I can break it into square root of the top and square root of the bottom. And now I'm simply going to get rid of the root in the denominator by multiplying by root 8. So in the numerator, we can multiply these together because they're both under roots. So we get root 24. On the bottom, we just get 8. Now the issue with this problem is the numerator needs to be simplified. I can break the square root of 24 into 2 factors, one of which is a perfect square. So I can break 24 into 4 and 6. The reason I would want to do that is because the square root of 4 can be simplified into 2. So we get 2 root 6 over 8. And then we can reduce the 2 and the 8. The 2 becomes a 1, the 8 becomes a 4. So my final simplified answer, square root of 6 all over 4. Now notice I didn't write the 1 in the front because the 1 is just understood to be there. Just like x is the same thing as 1 times x, the square root of 6 is the same thing as 1 times square root of 6. Very similar concept. So what we're going to do is we're going to use the skill that we just talked about in order to solve some problems involving what we are going to call special right triangles. There are 2 kinds of special right triangles. There are 45, 45, 90 triangles. The 45, 45, and 90 refer to the angle measures in each triangle. And there are also 30, 60, 90 triangles. The 30, 60, and 90 again reference the angles in the triangles. What we've learned, or what we learn about these, is that I can take each one of these special triangles and I can see that the ratios between the sides are going to be the same every single time. So give me 1 second. I'm going to open up a different file that's going to match more so what you have on your paper. Okay, so notice that, in a 45, 45, 90, you have 2 angles that are the same, which means that we have 2 sides that are the same. This is actually an isosceles right triangle. So what we know about these is that if it's an isosceles triangle, that means that my sides I have highlighted in blue, my legs, they have to be the exact same. So say that I make up a number like 6. So if I know that that's 6, then I know that the other leg also has to be 6 because it's an isosceles right triangle, 45, 45, 90. If I want to figure out what the hypotenuse is, I don't have to use Pythagorean theorem. I can just simply say it's one of the legs multiplied by the square root of 2, meaning that the hypotenuse would be 6 square root of 2. And that's just automatic. As soon as you recognize that you have a 45, 45, 90, your triangles, legs, and hypotenuse are always going to have this relationship. The hypotenuse is always the leg multiplied by the square root of 2. So coming down, looking at some extra problems down here. In my first problem, one of the legs is 4. That means that the other leg has to be 4 because it's an isosceles triangle. If I want to figure out the hypotenuse, it's leg multiplied by square root of 2. So just 4 square root of 2. Going backwards, it's the same concept. If I know the hypotenuse, we can figure out the legs by not multiplying by root 2, but instead by dividing by root 2. So if I divide by root 2, those cancel out, and we find out that each leg is a value of 3. Same concept with the next one, if I have 6 root 2 as the hypotenuse, I can find a leg by dividing by root 2. The root 2's would cancel out, and that tells me that each leg is a value of 6. So here's how we're going to look at each one of these. If I know one of the legs, all I do is multiply by root 2 to find the hypotenuse. If you want to go the other way around, say that you want to find a leg, like in the second and third problems, you're going to take the hypotenuse and you're going to divide by the square root of 2. So if you have a leg, multiply by root 2. If you have the hypotenuse, divide by root 2. So looking at the next few problems, the first thing you decide is, in this next problem, I have the hypotenuse. We just said, in order to find a leg, we're going to take the hypotenuse and divide by root 2. So we're going to do just that. I'm going to take the hypotenuse, I'm going to divide by the square root of 2. That's how I find a leg in a 45, 45, 90. Once you've done this, you're now going to have to simplify. That's why I showed you how to do that on the last slide. We're going to rationalize the denominator by multiplying by root 2, and we would end up with 12 square root of 2 all over 2. Just like on the last slide when we were simplifying, if you can reduce, you have to. The 12 and 2 reduce to 6 and 1, so you're left with a final answer of 6 square root of 2. In the next one, you realize that you're given a leg. In order to find the hypotenuse is always leg multiplied by root 2. So that means we're going to take the leg of root 6 and we're going to multiply by root 2. That will tell us the hypotenuse. So my hypotenuse comes out the square root of 12. Now what we have to realize is that's not the final answer, because the square root of 12 can be reduced into simplest radical form. So ask yourself the question, what perfect square divides evenly into 12? The answer to that is the 4. So I can break 12 into square root of 4 and square root of 3, which means my final answer is 2 square root of 3. That's the hypotenuse of the triangle. In the last one here, you're going to realize that that is the hypotenuse. If you want to know a leg, you're going to take hypotenuse and you're going to divide by root 2. So x is going to be hypotenuse divided by root 2. If you want to solve now, we have to simplify the denominator. So we're going to multiply by root 2, top and bottom. And I end up with a final answer of 5 square root of 2 all over 2. So in 45, 45, 90s, there's two things that are going to happen. You're either going to figure out a leg by dividing by root 2, or you're going to figure out the hypotenuse by multiplying by root 2. You just have to make the determination at the beginning of the problem, which of those things do I need to do? The harder of the special right triangles is the 30, 60, 90. The reason why it's harder is because none of the lengths are the same. They're all different. So what we're going to do is we're going to identify that the side length across from the 30-degree angle, we're going to call SL, meaning short leg. We're going to call the side length across from the 60-degree angle LL, long leg. And we're going to call the side across from the 90, obviously, the hypotenuse. So H, hypotenuse. So in any 30, 60, 90, there are three lengths you could be asked for: short leg, long leg, hypotenuse. So what we need to understand is that all of these things are based off of what is the short leg. So if you don't have the short leg, you have to find that first. If you have the short leg, the problem actually isn't that difficult. In order to find the hypotenuse, all you're going to do is double the short leg. So if the short leg was 4, the hypotenuse would be 8. In order to find the long leg, you're going to multiply the short leg by root 3. So again, if the short leg was 4, the long leg would be 4 root 3. So just a very basic number example here. If I told you that this was 10, that makes the hypotenuse double that, which is 20, and that makes the long leg 10 times the square root of 3. That pattern will hold true for any 30, 60, 90 triangle. So coming down, I believe that in this problem here, first I tell you that that length is 4 on your paper. So if I want to find the remaining sides, we have to identify what sides we're looking at. Across from the 60 is called the long leg. That is found by doing short times root 3. So my long leg is going to be 4 times root 3. And nicely, that doesn't simplify anymore. So we're done with that part of the problem. If I want to find the hypotenuse, hypotenuse is short times 2. So if I want to find my h, it's just 4 times 2, and my hypotenuse is a value of 8. So I was able to find the extra sides of that right triangle based solely off knowing the short leg of the triangle. In the next problem, again, I'm given the short leg. So if I want the long one, we're going to take short, and we're going to multiply by the square root of 3. Now, you may be looking at that kind of weird and asking yourself or saying to yourself, but it already has a root 3. Why would I multiply by another one? Well, the deal is, doesn't matter what the short leg is. If you want to find the long leg, you always multiply by root 3. Whether or not it already has a root doesn't matter. You always multiply by root 3. Now, multiplying these, if I multiply root 3 and root 3, I simply just get 3. That makes the long leg in this case 36. If I want to find the hypotenuse is short leg times 2. So I would do 12 root 3 multiplied by 2. Now remember, something that you learned last semester, and I went over with on the first slide, anytime you multiply numbers on the outside of roots, they go together. 12 times 2 is 24. The root 3 stays root 3. So we were able to figure out the long leg and the hypotenuse of the triangle. Last problem. This again is the short leg. So if I want the long leg, it's short times root 3. So we would have 3 root 2 times root 3. Okay, so properties of roots. Numbers inside roots get multiplied together. So this would stay 3. Root 2 and root 3 gives you just root 6. So there's your long leg. If you want the hypotenuse, double the short leg. So my hypotenuse is going to be 3 root 2 doubled, so multiplied by 2. Numbers outside of the root get multiplied together, so my final answer, 6 square root of 2. Okay, so what you may be thinking to yourself is, he's crazy if he thinks that I'm going to remember how and what to do with all of these pictures. So what I'll tell you is we're going to do a ton more examples in class. We're going to talk about a few more things that maybe we haven't talked about yet. And we're just going to do a ton of practice. So don't freak out yet on how hard this may seem, because the more problems you do and the more practice you get, the better you will get at doing these. Okay, so I promise you that you're going to get enough practice that this is going to become a lot easier for you. The first time you see 45, 45, 90 and 30, 60, 90, it's hard. So don't freak out yet. I promise you we are going to do plenty of examples together in class, and it will get easier. Please make sure that you talk about some specific examples or questions that you might have. If you flip over to the back, there's some extra practice there on the back if you'd like to attempt some of those problems. If not, we are definitely going to go over those problems in class next class, so make sure that you have your note sheet with you. As always, if you have questions, let me know.